right, so today we're going to be talking about 14.2, which is still in the probability unit. So far in probability, you guys have been looking at counting principles and basic probability. Now we're going to take that basic probability a step further and look at combinations and permutations and what we do if they're neither. Specifically today, you really should focus on how do I know if something's a combination versus how do I know if something's a permutation. Because what we do for combinations is going to be completely different than permutations. And really, my focus when I look at these is the difference between does it matter what order things are chosen in. So for combinations, the order does not matter. Okay, in other words, the order at which something is chosen doesn't matter. So for example, if we were talking about who crosses the finish line, what order people cross the finish line in that case order matters, because if I finish first, I'm doing the best, whereas if I finish fourth, I'm doing the worst. So in something like a race, the order in which I finish matters. But in something like if I were to choose just 4 students at random to get a free cookie, does it matter if I was choose first to get the free cookie or whether I was chose last to get the free cookie? No, it doesn't matter. It just matters that I am chosen as one of the 4 to get the free cookie. It doesn't matter does not matter if I was chosen first or fourth to get the free cookie. Doesn't matter if I was chosen first or fourth to get the free cookie. Just matters that I was chosen. Because all that matters is that I was chosen. This makes it a combination and not a permutation. Because in a permutation, it will matter. We will do permutations if it matters what order we were chosen in. But if it doesn't matter the order, it makes it a combination. Okay, now once we identify that it's a combination, we have to decide we have to use the combination formula. The combination formula is C of n comma r equals n factorial over the quantity n minus r factorial r factorial. Oops, sorry, that's a factorial sign. Now we need to know what each one of those things mean. The C just stands for combination. So once we identify that it's a combination, we're going to put that capital C. N stands for the number of elements. In other words, if we were talking about the number of students watching this video, let's say there were 90 of you, then there are 90. N is 90 because that's how many elements there are. R stands for the number of subset that is chosen. So for example, here we're choosing 4 of you, so 4 of you would be R. When we talk about this, it is often said that you can think of it as n things taken R at a time. Okay, so let's actually do some examples of this. So if we're looking at example 1 down here, right? In how many ways can 4 people be chosen from a group of 10? Again, if I'm just choosing randomly 4 people, it doesn't matter which person is chosen first or which person is chosen fourth. It just matters that you're chosen. So this is a combination because order doesn't matter. So every time you do one of these probability problems from now on, you need to decide, does order matter or not? If order does not matter, then we're going to do a combination. So I can start out with C. Now, C of n comma r means I need to identify what's the n and what's the r. Well, n is the total number of elements, so that tells me that my n is 10. R is the total chosen, which in this case is 4. So really we're doing C, and I want you to write down the formula. So C of n comma r is n factorial over n minus r factorial r factorial. The more times you write the formula, the more likely you are to remember it, so that on a test or a quiz you can actually recall it and do the formula. So in this case, my n is 10 and my r is 4. So it'd be 10 factorial over n minus r would be 10 minus 4 factorial. R would be 4 factorial. Now I would simplify that before I put that in my calculator to be 10 factorial over 6 factorial 4 factorial. And then we can just go to our calculator and type it in. So I'm going to make it a fraction to make life easier. So I'm going to use my fraction button. So 10, then remember you do math. You go over to the probability, and down here at 4 is the factorial. Then at 6, again math, probability, 4, math, scroll over to probability, factorial again is 4, which is 210. So when it says in how many ways can 4 people be chosen, there's 210 ways to choose 4 people. All right, let's look at number 2. How many ways can 4 people receive a cookie out of a group of 30, assuming no one receives more than 1 cookie? So again, does it matter whether I get chosen first, second, third, or fourth to get the cookie? No, it doesn't. So I know this is a combination because the order doesn't matter. Okay, so we're going to be doing the combination. C of n comma r equals n factorial over the quantity n minus r factorial, r factorial. So in this case, remembering that n is the total number of options, n is 30. And the people chosen is 4, so that's my 4, so r is 4. So n would be 30 factorial over 30 minus 4 factorial, 4 factorial. So that's 30 factorial over, because remember we can just do what's in the parentheses first, 30 minus 4 would be 26 factorial, 4 factorial. And then we can go ahead and get out our calculators and do that again. Now, if you didn't know where that fraction button is, you could type this in the long way. I like to make sure that I put parentheses around my numerator and parentheses around my denominator. So I would do 30 in parentheses, go over to probability, end my parenthesis because it's the end of my numerator, divide it by parenthesis, 26 factorial, 4 factorial, and then end my parentheses so that my calculator knows all of this is in the top of the fraction and all of this is in the bottom. And we end up with 27,405. So there's 27,405 ways to give 4 people cookies out of a group of 30. All right, now that seems pretty simple, but there is also a calculator shortcut for this. But remember, you're going to have to know these as well because at times you're going to have to do problems a little bit differently. So make sure you have that memorized. All right, as for our calculator shortcut, so I'm going to have my calculator over here on the side, clear everything out. You are basically going to be using a button that looks like this, NCR. So if you notice, the first term is the n, which is the total number of elements. So before I even go to my calculator to use this button in probability section, before I even go to use this, the first thing you should note is that this n comes first, which means that I'm going to have to find the n first. I'm going to have to type in the m first when I do this. So type in the number of elements first. Okay, so for example, let's do this one. My number of elements is 10. So I'm going to type in this one right now. Okay, my number of elements is 10, so we're going to type in a 10. Then we actually have to get to this NCR button. The way you get there is we have to get to that probability again. So you're going to go to math, right? You're going to scroll over till you get to the probability up here at the top. PRB, remember, stands for probability. And now, if you look at this, there's actually the NCR. So we're going to select the NCR. So I'm going to scroll down to 3, press enter. Notice now it says 10 is basically the number of elements. C, and then we're supposed to type in the R. And remember, so type in number of the subset, which is basically your R, right? Just like this one is basically your N. So you type in your N first. You go to probability. You find that NCR in the probability. And then you have to go ahead and type in the R amount, which in this case, my R amount is 4. So we're going to type in 4. And then literally just press enter. And if you notice, we get 210 up here, just like we would have typing in all the factorials. So this is a shortcut that's more than okay to use, but you will also need to know that formula at different times throughout the unit. So make sure you know how to do that both ways. So let's try number 3 and use our calculator to do it. So number 3 says use the calculator to find the number of ways 11 elements can be chosen from a group of 32. Okay, so again, the first thing we need to ask ourselves is, does order matter? Well, if I'm choosing just random elements and all of them are getting chosen, no particular order, there's not a necessary order, so this is a combination, because order does not matter. You really have to have that in your head. If order does not matter, then it is a combination. So we have to have C of n minus r. But if we're going to do our calculator, now we need to switch this to NCR. So to show my work, I need to definitely write this out. So I have to decide how many number of elements are there. Well, my n is 32. So this is 32C. And then my r is the total chosen, which is 11. So then we can go ahead, right? Go into our calculator, type in the 32, go to your math button, go over to probability, down to NCR, and then we're choosing 11 of them. Gives me this number here, so I'm going to move my calculators over so that I can write that down. So this is 129024480. So 129,000 or 129,024,480 ways to choose those 11 groups. Okay, so now you're going to go to the next video to see the permutations.